Can you hear me? Okay, good, good. So, so we have only three participants today, Sang. Only three: Chuang, Sang, and Tan. Only three of them. Okay. Anybody else? Wesley. Who's Wesley? Yeah, Wesley. What's your email? You're not registered for this class, Wesley. This is a storage networking class. Are you here for some new hire networking training or something? You guys will be learning about iSCSI. We'll see what iSCSI is and how it works. And then we'll talk about what is lossless Ethernet and then quality of service. I mean, these are things that I'll be covering today. Okay, so get ready. Let me get started. So, are you guys new to iSCSI? Did you hear about iSCSI? Worked on it? Sang, can you reply, please? Okay, Chuang. No problem. I'll explain, okay? Yes, okay, I'll explain. But request you to talk, reply me, okay? Okay, done. Thank you so much. Let's start. So, what is iSCSI? Before I talk about iSCSI, well, I need to talk about first what is SCSI. To understand the between two devices, if I take an example of any two devices, let's take an and some device. It could be a hard drive, for example. If these two devices have to talk to each other, if they have to talk, you need a language. The language is called as command set. So command set is what? Command set is nothing but a language spoken between two devices for communication. So for communication purpose, devices, they use a language to talk to each other. That's what you call as a command set. Okay. So between a controller and a device, there's a language that is spoken, and that language is called as command set. So we had a command set called as small computer system interface. Small computer system interface. It is a command set. Using this command set, SCSI command set, using SCSI commands, a controller will be able to send commands to its devices. What type of commands? Read command. It could be write command, or it could be for search. Yeah? The most common commands would be read, write, or search, which is C. This is a command set that is used between two devices to communicate. Now, When you talk about SCSI, like I said, SCSI, when it talks to SCSI devices, let's say SCSI device number one, device number two, device number three, yeah. Well, these devices, when they communicate, SCSI controller was using SCSI command set, and SCSI was sending those command set parallel. It was parallel communication. When you say parallel communication means when you say parallel communication, what happens with parallel communication is all these SCSI devices that you have, like SCSI hard drives, for example. I have three devices: SCSI SDD, SCSI SDD. All these devices that you have, these devices, they talk to the SCSI controller using a common cable. So let's say this is the common cable, and these SCSI devices that I'm talking about, they are connected using that common cable. They're all connected to that common cable. Doesn't matter how many devices. So SCSI, SCSI controller used to support total 15 devices, maximum 15 devices. But the speed was 320 megabytes per second, which is equivalent to 3 Gbps. So the bandwidth of this link, the link that you have, is 320 megabytes per second. So if you are using only one SCSI device, if you're using only one SCSI device, then that device will get the complete 320 megabytes per second speed. The moment I have one more devices added, let's say I add three devices, now the bandwidth is divided by three. It's like this 320 megabytes per second is going to be divided by 3. So they share the bandwidth. This is how parallel communication works. Parallel communication works. So this is how we had SCSI. So do you understand so far? Yes? No? Put it in chat. Just put a yes or a no in chat. Yeah. Okay. Thank you, Sang. Great. That's I like that. Yeah. So please keep replying. Okay. Thank you so much. So that's what you had as did for the same SCSI is they made the SCSI, they changed the parallel communication. They continued using the command set, SCSI command set. They are still using SCSI command set, but now instead of using parallel communication, they made it serial, and they started calling this as serial attached SCSI. Command set is still SCSI, but we will be using serial communication. Now, what is serial communication? In case of serial communication, what is happening is serial communication, if you look at it, in case of serial communication, these devices that you have, they have one to one connection. It's like if I have to make it clear, you can say that instead of using a common cable, they have one to one connection. This has a dedicated cable. This has a dedicated cable. This one has a dedicated cable. And what is the command set? Well, the command set is still SCSI. So you're still using command, SCSI commands, but you are sending it serial. It's being sent serially, one to one. So the good thing about one to one connection is you get dedicated bandwidth, and there is no sharing. This is what you call as serial attached SCSI. So in your PowerEdge servers, when you service your PowerEdge servers, you open it, have a look at it, you will see that there is a dedicated connection from your SAS drives to your SAS controller, and it's all serial, but still using SCSI commands. That's called as serial attached SCSI. And the speed, initially, the speeds of SAS were 3 Gbps, then 6, then 12 Gbps. If you talk about the latest speed, it'll be like 12 Gbps. Do you guys understand parallel SCSI and serial SCSI? Yes, no, please confirm. Parallel versus serial SCSI. Okay, thank you, Chuang. Next. Okay, now what is iSCSI? What is iSCSI? So when you talk about iSCSI, iSCSI, what you need to understand about iSCSI is the time. I mean, there was a time when we were using parallel SCSI, parallel SCSI, speed of 320 megabytes per second, which is equal to 3 Gbps. Yeah? So we were using this speed. Yeah, we were using this speed. So what we were looking at was like, okay, 320 megabytes per second. So at that time, there was a change in the industry in terms of the amount of data. So olden days, data was only generated by PCs, So there was less data coming to data centers. So, if you talk about 2 decades back, data was only generated by PCs, so less data was coming to data centers. So SCSI was perfect. I mean, for for that time. For that era, SCSI was great. And 320. I mean, the 320 megabytes per second speed was enough. Was sufficient. Yeah, was sufficient. Was good. Whatever you call it. So 320 megabytes per second speed was a good speed. When I say olden days, I'm talking about um, 2 decades back. 2 decades back, somewhere between 1990 to 2010 also. I mean, during these times, okay, 1990, I mean 1980, 1990, 2000, all these decades, okay. SCSI was there. There was less data. Data was only generated by PCs, so there was less data coming to your data center. SCSI was really doing great. I mean, it was perfect. Okay, SCSI was perfect. What actually changed was, you know, starting from 2011, you see this, the previous decade, right? Previous decade. Um, there's a lot more. I mean, there's more data. So I'll tell you what is the change. Okay, the change is we had a lot more data coming to our data centers. There's a lot more data that was coming to our data centers. Like, we had big data, cloud computing, yeah, social media, IoT, Internet of Things. So IoT would be like, it's not just PC that is generating data, but there are other things like other devices that there are other devices that are generating data, and those devices would be um, like your smartphones. Um, it could be your smart watches, smart gadgets, tablets, all that are generating data, sensors, yeah, they're generating data. So there is more data coming into our data centers. Now, with more data coming to our data centers, this speed of 320 was not good. This is a different era altogether. You see, big data, um, you're having more and more data, cloud computing, social media, IoT devices, Internet of Things. Yeah, all this is generating more data. So more data is coming to your data centers, and your data center has to, you know, your server, I mean, has to take more data and write it to the disk, and 320 Mbps speed was not good. So we were looking for, we had to improve. We had to improve. We had to improve on. We had to improve on. Um, what do you call? Um, we had to improve on, the speed of SCSI. We had to improve on speed of SCSI. 320 Mbps, not good for all this data coming in. Okay, so instead of developing new cable connectors, instead of developing new cables and connectors, we started looking for some existing technology that can carry SCSI traffic. That can carry SCSI traffic. And we found that IP network exists and has better speeds than original SCSI. It had better speeds. Than your original SCSI. Yeah. So we found that IP network is something there. With IP network, I don't have to develop new cables, new connectors. I don't have to do that. I don't have to do that and waste a lot of resources in developing new cables and connectors. I don't have to do that. I can just make use of some existing technology and I can make technology that can carry SCSI traffic. So IP network was there. IP network, IP, basically Ethernet. Ethernet had speeds of 10 Gbps. And SCSI was there at 3 Gbps. So Ethernet was a better choice. So SCSI was, if you look at SCSI was 3 Gbps. Ethernet was 10 Gbps. So we decided to send SCSI commands over IP network. We want to send the SCSI commands over IP network. We want to send that, SCSI commands over IP network. So SCSI commands to be sent over IP network. What is the benefit? What is the benefit of sending SCSI over IP? It's the benefit of sending SCSI over IP. Basically, iSCSI. Yeah, SCSI over IP. So what is the benefit of you sending SCSI, which is called as iSCSI? Advantage. Number one, better speed. You have better speeds than original SCSI. Yeah. Point number two, no need to set up new infrastructure. SCSI. No need to set up new infrastructure for SCSI. You can take make use of your IP infrastructure. Yeah, infrastructure. So it saves a lot of cost. Now you understand what is iSCSI, Chuang, Chuang Sang. Then do you guys understand iSCSI? Great. Okay, that's good. So we are talking about sending SCSI commands over. So let's say this is command. Okay, this is SCSI command. I would like to send the SCSI over IP network. Okay, I want to send the SCSI command over IP network. This SCSI command. Okay, I want to send this over your IP network. So let's see what can we do. Okay, um, so your SCSI commands have to travel from your server via the network and go to this iSCSI storage. Okay, so let's say I'll come up with something real quick to show you how it works. Okay, so if I look at storage over here, okay, so this is my storage. This is a server. This is the switch. And like I said, this is basically is the storage. You have a server, you have a switch, and you have a storage. Okay. Um, between these three, you know, between a server, switch, and a storage, what I see is a server has, for example, an IC card, is a NIC card, cable, is the switch, is another cable that connects to to the controller on the storage, and that's basically your, I mean, iSCSI port. It's a I. It's an iSCSI port. So if you look at this, your server talking to the storage. Yeah? This is all Ethernet. The one marked in blue, it's all Ethernet. So for me to send SCSI commands from the server to the iSCSI storage, what I need to do is I need to take this SCSI command and have your SCSI command being encapsulated. I mean, this has to be encapsulated, okay, and shown as, this has to be shown as your Ethernet. It has to encapsulate it, make it look like Ethernet frame, and you have to make this Ethernet frame of yours travel from this link all the way to this. And when it gets to this point, this is where you need to go ahead and extract SCSI commands, and it will go ahead and write the data to the SCSI disk. When you read, okay, it will go ahead and encapsulate SCSI controller on your iSCSI storage, will encapsulate it, make it look like an Ethernet frame. It will travel through this IP network, come to this NIC, and when it comes to this NIC, okay, the process is reverse, where it will decapsulate. It will take this and it will, process this. Yeah. So when you send, you do this. When you receive, you do the opposite. Okay? I mean, this is what you're doing. When you're sending, you're doing encapsulation. When you're receiving something, um, yeah, when you're receiving something, you go ahead and decapsulate it. So you do encapsulation and decapsulation. Encapsulate and decapsulate. This is what we are doing. Encapsulation and decapsulation. So, who does encapsulation and decapsulation? Like encapsulation. Encapsulation and decapsulation. Who does this? Encapsulation and decapsulation is done by us, iSCSI initiator. iSCSI initiator. So iSCSI initiator can be software or it can be hardware. Software initiator is like, for example, Microsoft iSCSI initiator, free. This is free. Hardware initiator, well, I mean, it's a hardware card. Okay, it's a card, um, and you have to buy this. Performance wise, which is better? Okay, this is, yeah, performance is better with your hardware iSCSI initiator. Performance wise, your hardware iSCSI initiator is better. Something similar to, okay, do you guys do RAID? Do you guys support? Do you guys support RAID? Yes, no, sang, chuang. Yeah. So it was a question. So hardware RAID, software RAID. Exactly. Hardware iSCSI initiator, software iSCSI initiator. Right. Similar. If you buy hardware iSCSI initiator, okay, it has its own CPU. It gives you better performance. But if you don't want to buy, you know, iSCSI initiator, hardware iSCSI initiator, then you can use the software initiator and you can do the job. Okay. So this is what iSCSI is. iSCSI is about taking your SCSI commands, taking your SCSI commands, encapsulating your SCSI commands, and making it look like an IP, packet, and then having this being sent over your IP network over to that iSCSI storage. And once it reaches the iSCSI storage, you extract it and then you execute these SCSI commands. When you're reading, when you want to read something, you go ahead and read things from the iSCSI storage, and it's all happening through SCSI. It's all happening through SCSI. So this is what iSCSI is. Okay, this is what iSCSI is. So okay, what this is a normal switch, and your iSCSI will work. This is a normal switch, normal NIC card. So you can either use NIC with software iSCSI initiator, or instead of using a NIC card, you can have an iSCSI hardware initiator called as iSCSI HBA. You can have an iSCSI HBA, which is a hardware. you know, iSCSI initiator. Either use this or you can use iSCSI. Either you can use this NIC or hardware iSCSI initiator. Okay, so you can have a NIC card or you can have a hardware iSCSI initiator. So that's what you can have. A NIC switch and server is called as initiator, which is called as target. So that means it's a storage. Okay, great. What next? Um, okay, now we know what is iSCSI. Okay, what is iSCSI? So I'll give you an example of, let's say, iSCSI. So let's say these are all, you know, virtual servers, LANs, different LANs that are mapped, like, you know, LAN 1, this is LAN 2, number 3, and number 4, 5, 6, and so on. So these are different LANs, okay, that are created on your storage. And the iSCSI port, will have an IP address to it. It could be 192, I don't know, 172.16.4 dot something. Okay, so let's say this is what you have on your um, iSCSI storage. Okay, let's say that's the IP. You will have some IP address over here. Some IP address 16.4 dot something. Okay, you'll have some IP address configured over here as your source IP address. Okay, source IP address. Let me have it as 10 or something. Okay, or yeah, okay. Let's have this one as some IP. Yeah. So what I'm saying is, like, if I have to show you iSCSI, okay, um, let me log in to one of the stations. Okay, machine. Um, the Windows machine has um, it will have by default, okay, some, okay. So this is the iSCSI, you know, that's the iSCSI software. Okay, wonderful. Yeah, so this is the Windows, and this Windows machine, let's say, has a NIC card with some IP address. Okay, so what is that NIC with an IP address? Um, for a Windows machine, it says for iSCSI, let's use 4.21, 172.16.4.21. Okay, that's the IP address, and I see Windows over here. Um, Yeah, 172.16.4.21. Okay, 4.21. So 172.16.4.21 is the IP address, right? You know, if you check IP config, you can see that in IP config, 172.16.4.21. That is the IP that is configured. Okay, 16.4.21. IP configured. And your, I mean, there's a iSCSI storage, which has got 172.16.4.32 as per this IP spreadsheet. Is your iSCSI on your compelling storage. You have 172.16.4.32. So that's your target. Okay. First, I'll go ahead and check if I'm able to ping the IP address of that iSCSI target. Okay, I'm able to ping to that target. Then I go ahead and use iSCSI initiator. Okay, initiator, and say discovery. Okay, you want to discover your 172.16.4.20. That's just because they like to discover. Just go ahead at um, 16.4.21, but is that 32, right? I'm sorry. Yeah, it's 172.16.4.2. I put that IP address. Yeah. So using iSCSI initiator software, I go ahead and talk to, you know, 172.16.4.32 is 172.16.4.32. That's your storage iSCSI port on your iSCSI storage, which has some LUNs, right? So you can see that once I go here and connect to that target over here, target listens. I mean, these are all sessions, so I can go ahead and choose them and say I would like to connect. These are all like multiple iSCSI, you know. So this is the connection that it says that okay, there's an iSCSI LUN or something configured on your compelling storage, and from your compelling storage, you're able to, you're able to talk to that compelling storage, and your iSCSI target is showing up, right? I mean, that's what it shows up, and then it and look into, you know, disk management. Maybe I need to scan or something. I should have some. It is taking some time, but yes, you will have those LUN coming up. Okay, over here, it's just the compellent story. But yes, if I look at iSCSI initiators, yeah, it has SCSI connection. Should be able to get the iSCSI LUNs over here. I can format, write a file system, and start using that as D drive or E drive. Guys, do you understand iSCSI, how it works? Okay, very good. Okay. Next. Um, okay, so this is good. Um, so your iSCSI, I mean your frames are actually traveling from the initiator. They go over to this switch. I mean, they are going through this switch and then getting to that storage. I mean, it's coming from that initiator going to the switch, and then it's going to that target. That's how it's working. So it's going through this Ethernet network. This is your Ethernet network. Okay, Ethernet network. Now, what you have to know about um, iSCSI is iSCSI can go on a normal Ethernet. I mean, this packet can flow through normal Ethernet, no problem. Okay, great. And I told you the benefit, right? I mean, the benefit of you sending SCSI over IP network is better speed. So better speed. I told you SCSI was 3 Gbps, and if you look at your IP, right? IP network was 10 Gbps. Okay, Ethernet had speeds of 10 Gbps. This was long back. Today, if you ask me, okay, the speeds, the speeds of Ethernet today, right, has speeds of 10. I mean, it already had 10, right? I mean, Ethernet had 1, 10. It has 25 Gbps, 40 Gbps, 50 Gbps, 100 Gbps as well. This is the speed at which Ethernet is working today. Thinkers, because fit today. Isn't Ethernet fast? If you look at the speeds, original SCSI was 3 Gbps. Look at Ethernet speeds 1, 10, 25, 40, 50, 100. The latest is 200 Gbps. So it's very fast, your Ethernet network. Okay. So, yeah, so that's something that you have to know. And then maybe um, the next thing that I want to talk was I wanted to actually talk about um, the next topic would be after iSCSI. The next topic would be um, fiber channel over Ethernet, like sending. Like we are sending, um, like we are sending SCSI or IP, because IP network is fast. We can send fiber channel also, okay? Fiber channel frames over Ethernet network by doing exactly the same thing. Encapsulation and decapsulation. We can do that. And we can send things, we can make things faster, okay? By sending it over Ethernet. So, okay, which is what we discussed right on day one. If you look at it, the whole discussion on day one was how, you know being sent over. Day one goes to the C switch, and I mean FC storage. This was the plan, right? It all starts from here. It goes storage altogether, right? And then here goes the OE switch, and from the FCOE switch, it's going to go and travel to that FC storage. It's going to travel to that FC storage, and when you're replying back from that FC storage, things are going to come back to the FC from the FCOE switch. It gets translated as FCOE, comes to the CNA card, and then the CNA card will go ahead and decapsulate it and do what your FC is supposed to do. Yeah. So that's something that we want to do. So yeah, so what I'm saying is, like, for you to go ahead and achieve that, for you to do this, you have to look at Ethernet. Look, Ethernet network is a lossy network. When you say lossy, that means it has packet loss. So, but your fiber channel is a lossless network. When you say lossy network, that means you can have packet losses. When you say lossless network, when you say lossless network, that means your fiber channel frames, they don't get dropped. There are no fiber channel frames that are getting dropped. So it's a reliable network. Okay. Lossless Ethernet, meaning drop. But the problem with Ethernet network is, Ethernet network is a lossy network. You have some packet network. Fiber channel is known for reliability. There are no packet losses happening in fiber channel, original fiber channel. If you look at how things were, right? Let me show you that real quick. So if I go to, what is it? I was talking about converged networking, right? Let me do that. Converged networking. So if you look at the original, traditional network. Look at traditional network. Traditional network. This is a separate network, separate, marked orange or maybe red, just to show you that this is a separate network. And what used to happen with this network is piece of traditional network, there was a separate FC network. And FC is known for reliability. So packs I/O from the network to the FC switch to the FC fabric to the FC storage. I mean, this is going to go through all this, and there are absolutely no power losses that are and used to it and have its own network. So this network, this is a lossy network, and this is a lossless. There's a lossy and a lossless network. I mean, fiber channel known for reliability, Ethernet known for, Ethernet known for um, it's a lossy network, whereas fiber channel is known for reliability. It's lossless. So the network so channel travel without any packet drops. You should travel on fiber channel network. But now you're saying that okay, no, let's go ahead, converge these two traffic, and have it sent over a single link. Let's send the fiber channel frames on Ethernet link by having it encapsulated as an Ethernet frame. We'll be going ahead and sending this one through Ethernet link to the FCOE switch, and from the FCOE switch, it will travel to that concerned destination. So the point is, your fiber channel is actually traveling through this Ethernet link, and that's exactly what I'm saying that hey, look, your Ethernet link over here is a lossy network. You're gonna have it loss. But FC is known for reliability. I don't want to lose my fiber channel frames just because I'm sending this on Ethernet link. I don't want to have this thing dropped. So all of you, okay. Now what I have written over here, send which over Ethernet, there is a risk of drop because Ethernet network is lossy network. So I want Ethernet to become lossless. Yeah. So if I want Ethernet to become lossless, I have to do something. And only when it's lossless, then I should be able to send my FC frames over Ethernet network because is known for, FC is known for reliability. FC, Ethernet network to be lossless. Okay. So how to make your Ethernet lossless? How can I make my Ethernet network strong? So what FC recommends? It recommends you to implement use center bridge technique to make your Ethernet lossless. Okay, so what is data center bridging? Data center bridging, okay, is standard, has set of standards. Number one, priority flow control. Two, enhanced transmission selection. Three, D6, PFC, ETS, TBX. There are three standards, which is what is, okay. DCB is not a standard, but it has PETS. If you see, your Ethernet network will become strong. It becomes lossless. Okay. So and DCB is a must. You have to make sure that you're implementing data center bridging for fiber channel Ethernet implementation. For your FCOE implementation, DCB is a must. You have to do it. So what is DCB? Has three protocols: PFC, ETS, DCBX. Okay, so we'll learn about PFC. PFC stands for priority flow control. ETS, ETS, enhance transmission selection. Okay, data center bridging exchange. This is what DCBX is. PFC, ETS, DCBX. Data center. So, what is priority flow control? What is ETS? What is DCBX? After a break. Do you guys want a break? Okay, take a 15-minute break. We'll resume at 11:20 p.m. Vietnam time. Okay, thank you. You're welcome.
cùng những thăng trầm
question to the instructor. Instructor is this guy. I told you that he's the instructor. Okay, here we go. So I'm the instructor. Sang is going to ask a question to instructor. Okay. So Sang wants to know, some query like whether in India how's the COVID situation in India, etc., etc. So Sang is asking this question to the so instructor is replying to the queries. Okay, to the queries. So instructor replies to the queries. Okay, instructor is trying to reply to the query. At the same time, I see Chuang is asking a question to the instructor, saying, "Hey, Nadeem, hey Nadeem, I have some problem with my lab. I need your help to fix the issue. So I have some problem with my lab or issue with my lab, and I need your help to fix the issue." Yep, so that's coming from Chuang. Instructor is saying, "Hey, instructor replies, replies, hey, I'm busy." Is being made busy by Sang. Sang is asking questions. How's the weather in India? How's the COVID situation in India? Um, are the schools reopening? Are the offices reopening? Yeah, so continuously, Sang is asking questions to the instructor. So instructor is busy. At the same time, I see Chuang asking a question, saying, "Hey, I have some problem with my iSCSI lab. This is not working. That is not working. I need your help." That is what Chuang is. That's why Chuang is reaching out to the instructor. And the instructor, Nadeem, is replying to him saying that, "Hey, I'm busy." This is what the instructor is replying to Chuang. Chuang over here is just waiting. He is waiting so that the instructor is free. I mean, once Sang finishes all his questions and the instructor is free, the instructor can look into my issue and I can answer my question or solution to my solution to my problem. Okay, so out of these two questions, like two students, Sang and Chuang, student questions are more important. Guys, between Sang and Chuang, which student questions are more important? Sang questions? Yeah, simple. Yeah, go ahead. Sang or Chuang questions? Which student question is more important? Which question needs to be answered by the instructor? Sang first or Chuang first? Please answer. Chuang, full general question. Okay. Come on, guys. Who is more important? Yes, Chuang. Go ahead. Answer. Yes, Chuang says he's important. What about Sang? Sang, what do you think? Sang thinks is more important. Strong. 10. Guys, respond to the query, okay? Sang says Sang is important. Well, actually, if you look at it, you're in a class, and this class is meant for learning about, learning about networking, okay? It's about, you know, it's meant for learning about networking, not for asking general questions like, okay, how's the weather or COVID situation in India or when is the office reopening? That's not what is important. That's not what this training is. I mean, why you are here? You're here to learn about networking. You're here to learn about some product. So your questions about that course is should be answered first. Should be answered first. And only after answering those questions first, then if you have bandwidth, you can go ahead and answer their general queries. Like, hey, what did you have for breakfast? What time, what do you usually, um, go to office or start your work? Things like that, like general questions. You can actually have all those general questions answered later. But what is more important? Okay, questions relevant to the course. So in this scenario, okay, Chuang questions are more important and they need to be answered first. Sang questions are general questions and can be made to wait and answered later. Do you all agree? Very good. So, this is priority. I mean, earlier, flow control in a switch, what does is it doesn't look at which is more important. It doesn't look at which is more important. So when your switch is busy, it'll stop all the traffic saying, hey, I'm busy, please wait. It doesn't understand like which is more important and which is, um, important. Like, I mean, it doesn't look at busy. It will say that it's busy and it'll stop all traffic. That's the problem with flow control. So what FCOE says is don't use flow control. Instead of using flow control, use priority flow control. So, in a priority flow control, in this, what I'm having questions coming from Sang and questions coming from Chuang. So between Sang and Chuang question, I will go ahead and give these questions high priority. Would be on low priority. Priority. So the ones on high priority will be allowed. I'll process this. This, the one which is on low priority. So this is the low priority one, right? So the low priority one will be made to wait. I mean, it's gonna go ahead and make that thing wait, saying that hey, um, that question because between these two queries, this query is important. So it prioritizes traffic and then allows that traffic and traffic which is of low priority, it can pause that traffic. So that's what priority flow control is. I mean, this is what priority flow control is saying that flow control is going to stop all traffic. But priority flow control, it's going to pause specific traffic only. Okay, that's going to pause specific traffic only. I mean, that's if you look at it, PFC, yeah, they're asking you. He is actually recommending you to have priority flow control. Would be, priority flow control. It's about prioritizing, what traffic to be allowed and what traffic to be paused is something that flow control. Are you clear with this? Do you guys understand priority flow control? Okay, priority flow control. Great. Well, the next thing that I'll be talking about would be what is mission enhanced transmission selection. So if you're looking at enhanced transmission selection, which is ETS, okay, if if you Look at your normal Ethernet. Okay, so what are we doing? This used to be like dedicated bandwidth. This to be dedicated bandwidth, which all this traffic used to flow. It used to flow on a separate link altogether. No sharing. It's used to flow on a separate link altogether. There's no sharing happening over here either, right? When you look at converged networking, you're talking about sending your Ethernet frame and your FCOE frames. Like both these frames are actually going through the same link, right? Your Ethernet and FCOE, both these traffic is going on the same link. So when you're going on the same link, this is like a 10 gig link. Okay, so this is like a 10 Gbps link. For Ethernet and FCOE traffic, these two traffic types on the same link. So the idea is, okay, you've got these two traffic types going on the same link, and going on the same link. Now, you going on that same link, the problem is, I don't want, let's say this 10 gig link that you have, for example, this is the 10 gig link. If this is the 10 gig link, on this 10 gig link, you said Ethernet and FCOE both going to the same link, right? I mean, within this link, you have Ethernet and FCOE traffic flowing. But what if your Ethernet traffic is eating up the complete 10 gig? I mean, it's taking up the complete 10 gig. Then what? It's all Ethernet. Ethernet here. I mean, Ethernet here. It has taken up the complete bandwidth. And only after your Ethernet traffic goes through, your FCOE can pass. That's because the bandwidth was the bandwidth was completely eaten up by Ethernet traffic. So your FCOE traffic has to wait. I don't want that. I know that there are two different traffic types going through the same, but I don't want one traffic to monopolize the entire bandwidth. And there's no room for FCOE. So I would like to do some bandwidth reserve, some bandwidth. So for example, on this CNA card, okay, for Ethernet, let's say I reserve 40%. And for FCOE, Ethernet marked in green, FCOE marked in purple color, right? So within that link, what I see is 60% bandwidth will be reserved. So your FCOE within that same link can go through that 60% bandwidth. Whereas your Ethernet will be the one that will be using that 40%. So that way, both Ethernet and FCOE can go through the same link without monopolizing the entire bandwidth. So you're doing bandwidth reservation, in short. Because check this out. I mean, this is exactly what is happening, sir. If this is something that you have as your 10 gig link, and within that 10 gig link, what I see is like you've got Ethernet and FCOE, right? Traffic to be flowing. So what I'm doing is like 60% is what I'm reserving for my FCOE, and for something that my my Ethernet traffic can use that 40% bandwidth, and it can actually go through that link. whereas the 60% that I'm talking about is what the FCOE uses, and it goes right. So in short, when you talk about enhanced transmission selection, it talks about with the way. Are you guys clear with ETS? Do you understand ETS transmission section? Yes, no. Okay, very good. So enhanced transmission selection is, and the last piece would be our data center bridging exchange. Okay, the third. So we have to make sure, okay, that this protocol is also enable data center bridging exchange. Okay, something that we have to configure. So what your DCBX basically do? Um, so what your DCX basically does is imagine okay, you have set 40 60 on the CNA card. So on your CNA card, great. I want a same bandwidth reservation, same priority to be given from this point all the way till I reach this point, from start to end, from start Ethernet to the end of that. I want the same treatment, same priority being given. Yeah. So 40%, 60%. I want the same 40 and 60 here. I want the same 40 and 60 everywhere, wherever you have Ethernet, because when you're talking about, like, sending your data, right? Um, if I have to go FCOE, maybe instant FCOE switch. Are you getting the same thing? Okay. Are you doing the same? For example, if I go ahead and look at something set up, you've got this FCOE, okay, this CNA. Okay, so 60% bandwidth that comes to MXL. What about this MXL? You get steep here when you're traveling from MXL to your S4148. Are you getting 60% band 48? 60, 60, 60? Or is it please, and then who ensures, who is making sure that your priority, you're being given the same priority and the same bandwidth, preferential treatment throughout your Ethernet network? This is a job done by DCBX. Your DCBX protocol will check your DCBX as a project. Hey, this is what is configured here. Is it the same thing here? Is it matching or not? If it matches, it's okay. It's matching, like, okay, here 50% match, so it gives you an error, and there's an option to to correct that error as well, where you can automatically correct this behavior. So who ensures your priority settings? Well, that's the job of your data center bridging exchange protocol, DCBX. Hope you got it. You and all of you. So, what are the three what are the three protocols? What are the three protocols of DCP? Who can answer? What are three protocols of data center bridging? Sang, Chuang, Trong. Yeah, go ahead. Go ahead. Yeah, go ahead, Chuang. There is nothing right or wrong. Okay, we are here. Three protocols of DCB. Sang, three. What are the three protocols of DCB? Data center transfer protocols. Three standards of DCB. Okay, three standards. Standard number one of DCB will be priority flow control. Standard number two of data center bridging will be enhanced transmission. Standard number three would be data center bridging exchange protocol. This is what I was asking. Okay? Yeah, very good. Now, if you want to do FCOE, fiber channel, data center bridging is a must. DCB is a must for FCOE implementation. DCB is a must. You have to do data center bridging, which means PFC, ETS, DCBX. You have to do these for FCOE implementation. For FCOE implementation. And what's the other thing that I said? The other thing was, yeah, for FCOE, DCB is a must. But DCB a must for iSCSI. And over, if you are sending, if you're sending it over DCB enabled lossless Ethernet, it is always going to be better. So if you're sending it over DCB enabled lossless Ethernet, it is going to be better because your network is lossless. Do you guys agree with this? Yes or no? Data center bridging is not a requirement for iSCSI. But if you implement DCB, your Ethernet network is going to be lossless, strong, no packet drop. It is going to be better, right? Your iSCSI packets will not get dropped. Agree, yes or no? So, do you want to agree or not? Saying that DCB is, is not a requirement for iSCSI. Um, but yeah, yes, if you implement DCB, your network is going to be strong. There is no packet drop, so iSCSI can benefit, okay, from this one. So when you guys come back or say lunch break, I'll be explaining you how to prioritize one traffic, one type of traffic over the other type of traffic. How we can do prioritization. Okay, so that's something that we will learn. We'll learn about QoS. We'll learn, okay, how to prioritize traffic in Ethernet network. Technology is called as QoS, stands for quality of service. Okay, local time in Vietnam, I think it's about close to 12, close to 12 in Vietnam. Okay, so you can take your lunch break, lunch will resume at 1 p.m. Thank you. In Ethernet network. So the technology OS, which stands for quality of service and service too. Now, what a QoS does is suppose you've got these two. This is voice over IP, and this is your voice over IP phone and your PC. Let's say they're connected to this switch over here. I mean, this is the switch to which they are connected. So your voice traffic and this voice traffic. Okay, let me type it. The voice traffic. I'm gonna go ahead and mark this in some color. Maybe we can use voice traffic created by IP phone, and this is your data traffic. Say there are different and data traffic, which is marked in red. They both get to that switch. I mean, they come to this switch, and from this switch, they want to make an exit. I mean, they both want to actually go out to that external network. You know, we have port number 10. They want to go to that external network. I mean, both voice and now, out of these two traffic types, remember, let's say, yeah, out of these two, voice and data traffic, your voice traffic is important, and you want voice traffic to be processed first, prioritized and processed first. I mean, that's what you're looking at. So between these two traffic types, your voice traffic and your data traffic, I see that your voice traffic is more important, and you want your voice traffic to be processed first. So you want is when it comes to exit, I mean, when they are going out of port number 10, I want this traffic to go first. I want this thing to go in this order. I mean, I want all my voice traffic to go first. This is what I want. I want voice to go out first, and then I don't want, something like, I mean, this is what I want. I want voice traffic to go out first. I, uh, I don't want my data traffic to go first. No, I don't want data traffic to go first. I want my voice first and then the data traffic, because traffic is more important. It's sensitive, so I want voice to be processed first. So this is what this is how I want now to be that port number 10. So normally, if you don't figure anything on the switch might send this out first, or maybe the switch can send your data traffic, depending upon whatever traffic it chooses to. It can send any traffic out, okay, first. But like I said, I don't want that behavior of data going on. So I want my switch to go ahead and help me achieve this. Yeah, I want this. So how does your switch do it? Like, I mean, how does your switch end up prioritizing, okay, traffic over the other? Okay, how does your switch do? Let's have a look at it. When these packets they arrive, okay, when these packets, when they go to the switch number one has to find the traffic. Which traffic you want to prioritize, this or this? How does your switch identify the traffic? You're telling the switch by writing a rule called as ACL, access control list. This is just the name of the rule saying allow traffic dot. So if you look at your voice over IP devices, they're all using 10.1.1.0 network, okay, IP addresses. So the packet over here will have a source IP address of 10.x. The packet over here will have a source IP 20.x. So I have written a rule over here saying allow traffic with the source IP of 10 network trying to go to any destination, okay, any. So when this traffic comes in, the switch will identify all traffic which has got a source IP address of 10.x. It will go ahead and give a number. It will give a priority number, okay. So let's say the traffic that is identified as 10.x, that's being given a priority number. Let's say the priority is something. For example, priority number 3. Okay, that's the priority that we are giving. I give the priority number 3. The traffic is originating, like I said, yeah. So all that 10 dot, x will get a priority. So priority. Now, once you have a priority number being assigned, yeah. So this is the number as tagging. We'll go ahead and give a tag, a priority number to that packet. So the packet gets a priority number. Once the packet gets the priority number, step number 3 is to map it to the hardware queue. Now, what is a hardware queue? Okay, what is a hardware queue? Now, hardware queue is these are physical queues within the switch where the packets are kept before they are processed. These are physical queues. So in this example, okay, we have 4 hardware queues. Okay, um, actually high end. If you look at high end switches, support maximum queues. If you talk about the high end switches will have up to 8 hardware queues. As an example, I'm taking only 4 hardware queues. Do is we have to go ahead and map that traffic with the priority number to a hardware queue. So let's say this traffic with the priority number of 3 was mapped to hardware queue number 2. It is mapped to hardware queue number 2. Um, and then out of these queues, whether you have 4 or you have 8 queues, only one queue can be marked as strict. Only one queue can be marked as strict. And that queue, let's say we make it as Q2, we go to Q2 and say strict. So what does strict mean? Strict means whatever traffic, whatever traffic that you have in this queue, let's say this was mapped, this was something Q2. So whatever traffic is there in this queue should be processed first. Only after processing this queue, the other queues that you have, like, whether it's queue, I don't know, like, you got Q3, you've got Q4, you got whatever other queues, right? Processed in round robin fashion, round robin. These are all going to be round robin. Only one queue can be marked as strict. So since your packet with a priority number of 3 was actually mapped to queue is marked as strict, from all these traffics that you have right now, I see that this is something that will be processed first, and the remaining traffic will be processed in round robin fashion. You understand so far? Very good. Next. Okay, let's talk about priority numbers. You said, right? P3. So priority number. See, priority numbers can be given using two different methods. I should say there are two different ways, two different methods. Number one, method one would be, it's called as dot 1p. Actually, it is like 802.1p. Okay. We call it as dot 1p in short. So 802.1p. So what is this 802.1p? 802.1p has 8 priority numbers starting from 0 to 7. So 0, 1, 2, 3, 4, 5, 6, and 2, 3, 4. So it has 8 priority numbers starting from 0 all the way to, okay, 0 to 7. So you can use 802.1p dot 1p method, or you can use DS, which stands for differentiated services code point. Okay, DSCP. Now DSCP has 64 values ranging from 0 all the way to 6. Yeah, 0, 1, 2, 3, 4, all the way to 63. So it has 64 priority values. Whereas 802.1p, like I said, it's got, you know, 8 values starting from 0 all the way to, 7, but this one is starting from 0 all the way to 63. You guys are clear with this so far? Okay. Now, you might have a question saying that, hey, um, so hey, does higher number mean higher or better priority? Question. I mean, this is the question. Like, hey, does higher number priority or better priority? Well, the answer to that one would be no. Higher number does not mean better priority. Better priority depends on which queue the traffic is mapped to. It depends on which traffic you are mapped to. For example, In this example, this P was mapped to hardware queue number one. And if this had a priority of something, let's say P0, priority 0, and if this was mapped to this, then out of these two, out of this and this traffic, it is this traffic that will, out of these two, since you're, okay, now this one is mapped to this one, right? Okay, hold on a second. So this is mapped to Q1. Let's say this is mapped to Q, because Q2 is marked as strict. Q2 is marked as strict, and this data is mapped to Q2, and Q2 is strict. Out of traffic blue and traffic red will be processed first. Do you understand? Okay, so let's have a look at some real life example. Have a look at this. Let's say look at this. Let's say you're boarding an airline. Okay, so you go to the counter first to get a boarding pass. So they have to first identify their passengers. Out of all the passengers that they have, what category of passenger you are. They have to classify those passengers. Okay, so like we did it over here, if you look at it, we are talking about identifying traffic from all the given passengers. We go ahead and start identifying that, okay, these are economy class, business class, cabin crew, senior citizens, especially children. So these are all my, that is what I'm doing. I identify the traffic, identify my passengers. And then I start marking them. I start giving them a code. Okay. So the code could be like anything, like let's say P012 code for economy. Business class P3, this is P4, P5, P6, P7. I can give it that way. Or you might think of a code in real life. You can think of a code something like, okay, business class BC, yeah, and then cabin crew CC. Um, you're just talking about the code, okay? Some code, senior citizens SC, um, WC meaning woman and children. Yeah, so let's say, um, so these are all the codes that, and what is important is after you give them, the code, it's important that right in front of the boarding gate, there are full queues. Let's say there are four queues, for you to board that flight, to get into that boarding gate and board the flight. And these four queues, okay, out of these four queues, there's one queue that is marked as strict. And if your business class code E3, yeah, if they are allowed, if they are mapped to queue number one and Q1 is strict, in that case, what is happening is your business class will be the one that will be boarding first. They'll be the one that'll be boarding first because their queue is marked as strict. Only after business class is done, the remaining queues, Q0, Q2, Q3, they will be processed. Yeah, guys, did this example help you understand what is quality of service? Okay, very good. That's exactly, if you look at it real time, right? So what we are doing over here, the different class of types of passengers that I was talking about all this while will be referred as traffic class, also known as QoS group, also known as priority group. So you got traffic class, QoS group, and priority group. There are different terms that are used in different versions of operating system. It's nothing but the type of traffic, and that traffic needs to be, given some kind of a tag. So let's say if you're using .1p, you can give priorities like 0 to 7, and these are your actual hardware queues. 0 to 3 as an example, four hardware queues, 0, 1, 2, 3, and that's the exit port. I mean the boarding gate. Yeah. So keeping this logic in mind, okay, let's try to let's try to achieve this, identify traffic and all this in a real time example. So the example that I have over here would obviously be if, you know um, let's say, yeah. So let's see what we can do, how to identify traffic. Okay, so basically what is happening is switch A, and this switch has a port to which your phone and your PC are connected. They are coming to this switch on port 0. They are connected to this switch on port 0. And this switch has port number 5, which is connecting to an external network. Yeah. So you got port 0, you got port number 5 that are connecting, port 0 to which voice over IP traffic and end user traffic comes in. And voice over IP traffic is using 192 network, whereas end users are part of 172 network. And they both want to go to that external net. Out of these two type of traffic, like voice and end user traffic, your PC traffic, what I'm trying to do is I want my voice traffic, my phone traffic, to be going out first. I want this traffic, when both of them get to that switch, these two get to that switch. I know that they'll be traveling to the switch, and then from the switch, what I want is I want my voice over IP traffic to be going out first. I want my voice traffic to be going out first, and only then the end user traffic. That's the plan. Okay, so in order to make sure prioritize voice traffic or other types, we first start with identify. How do I let the switch know which traffic to prioritize? So we do step one, which is to traffic. Identifying traffic, we are creating an ACL. As you can see here, This is an ACL. Okay, this is just a name. The ACL says the name is my ACL. Okay, what is your ACL doing? Saying traffic of 192.168.10.0 allowed. Okay, so we create a map called as class map. Now, what is class map doing with? Now, class map is the one that deals with identification. This is the one that identifies the traffic. Okay, the one that identifies the traffic. Class map. Because if you look at your class map, right, it says class map. The name of the class map is my class map. Okay, my class map. Okay, class map. The class map says what traffic. Okay, the traffic that was filtered by my ACL. If you look at it, it's deals which part of my ACL. My ACL has 192.168.10.0. So in short, we are saying 192.168.10.0 traffic. Okay, that's the traffic that we would like to prioritize. Okay, um, fine. We know what traffic with you know tagging, what priority number you want to give. So for priority number, you can see I'm creating a QoS policy. I mean, there is a policy that is created for traffic that is coming into port number 0 input. So it says, I mean, this is just a policy name. You can give any name to this policy, but yeah, here it is. This is a policy name. And if you look at it, it says set the priority number to 32. It says the priority number that we'll be using 32. That's the priority number. And so this basically deals with, you know, what priority to be given. Okay. And then if you look at, mapping it to a hardware queue, when you talk about mapping it to a hardware queue, you would actually see that I'm creating a policy. Okay. The name of the policy map is my input policy map. You can give any name. Okay. But let's say this is the policy map. And what is the policy map doing? Is just traffic of my hyphen class. If you look at this, which I'm marking it in, green, my class map, which is marked in green. So we are talking about this traffic over here, traffic 9268. So your policy map says whatever traffic is part of class map, called as my class map, that traffic needs to be hardware queue number two, with a priority. You can see the priority. The priority is 32 because over here we are using that same QoS policy. So you can see the QoS policy over here. What is the QoS policy? The QoS policy is this orange. So traffic 192.168 should be given a priority of 32, and it should be mapped to hardware queue number 2. This is service queue 2. You can see 192.168 traffic, okay, will be given a priority of 32, which we have configured over here as part of this policy, and it should be mapped to hardware queue number 2. Okay, and what about what about making queue number 2 as strict? Okay, now here is that command for you to go ahead and make that thing as a strict queue. We are going ahead and saying that strict priority hardware queue number 2, should be marked with strict priority. So this queue is marked, and that entire policy that you created, right? The blue color policy, my input policy. Yeah, this policy, which includes what hardware queue, all these details, which are part of this policy, we are going to this interface 0. We go and applying this on interface 0. So as you can see over here, I go to interface 0 and say service policy for incoming traffic that basically comes into port number 0. Okay, the policy name is my hyphen input hyphen policy map. My hyphen input hyphen policy map. This is a policy that we are applying on port number 0 of switch A. What does this policy contain? The policy contains a class map, which means 190 to 168 traffic, contains the priority number, the QoS policy 32, which hardware queue, queue number 2, all these part of this policy map. And this policy map is what is applied, what is being applied on port number 0, and then on port number 0. And I mean, you go ahead and apply that on port number. That's about it. So any traffic that comes in, it will go ahead and make sure that it, uses, it uses this policy, and then, and then does the traffic. I mean, it will take that policy and it will go ahead and first identify traffic, map it to hardware queue number 2, and then this queue is strict, so it's going to process queue 2 first. Is it clear, all of you? Hey guys, do you understand quality of service? Yes, no? Okay. Second, do you all configure RAID in PE servers? What about the rest? Chuang, Trung, TC10. Do you guys configure RAID or not in servers? Yes, no? Thank you, Sang. What about others? Can you check with them, please? It's a simple question. Okay, yes. So configuring RAID in OMSA, okay, let me ask you this question. Different RAID controllers have different interface. Yes. No, Sang. Okay, you configuring RAID on your perk 6 versus a different RAID control is the interface is different. I mean, the interface looks different. On PowerEdge servers only, I'm saying. On PowerEdge servers, If you look at old controllers and not more. And what is Chuang? What do you want to say? Yes, go ahead, Chuang. Okay. See. Okay. Um. Okay. Withdraw cash from ATM. Come on, general question. Simple question. Withdraw from ATM machines. Eight different have face different options. Yes or no? Very good. They have different interface looks, but end of the day, we but the concept is same. To withdraw cash. Maybe options are different. What banks do you have in Vietnam? Have in Vietnam. Guys, you have in Vietnam. In Vietnam. Okay. Techcom. Techcom Bank. Okay. Hmm. Good. Great. 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 So, do they all have face or different interface? Do they have same interface or they have different interface when you withdraw cash? Their ATM machines. Yes, but you know how to with but all of so the concept is same with draw caps. Now, okay, in a different place would be different. Yeah, exactly. You need when you configure different versions of switch operating will have different commands, but says to the concept is same. Identify in concept the same. You'll identify tracking traffic, mapping it to a hardware queue, and making it as strict. I'll give you an example of this one. Have a look at one operating system version. Some I'll show you an example of another one, a different OS. Altogether. Have a look at this one. Say they are using port number 448 here. Okay. Port number. Okay. What are they trying to do? Switch A, different traffic, and use external network, and this is the switch that you have, and the console. If you look at it for that switch commands over here, they're directly saying that okay, class map. What is class map dealing with? Class map, this is the name of the class map. Class map dealing with. Now, class map deals with any traffic with 192.168.10.0, which is basically this. So that's what class map is dealing with. In short, your class map is actually dealing with identifying, identifying traffic. I mean, if you look at this is what you do. You're trying to identify by using this. That's a class map saying anybody with a source IP of 172, 192.168.10.0. That is to identify traffic. Okay, how are they marking the traffic? Okay, let's have a look at this. Point number two. How is it that they are marking? So they are directly using a policy map called as policy match hyphen IP for all the incoming traffic, the traffic that comes in. Okay, for incoming traffic. What are they doing? So they are saying that traffic class map name is class hyphen match hyphen IP. If you look at this class hyphen match hyphen IP, so this traffic, which means 192.168.10.0 traffic, given 30. So you are tagging that traffic, marking that traffic, and then okay, mapping it to a hardware queue. I don't have a screenshot mapping it to a hardware queue, but I have a screen talks about how you can go ahead and configure a particular queue as a strict queue. Okay, and all that you're doing is, if you look at this QoS, this is class of service queue. Queue number two is marked as strict. Queue number two is marked as strict. So that's what you are actually doing, and I mean that's exactly what you did over here. If you look at how you queue as strict, queue number two as strict, look at the command. Both are marking queue number two as strict, queue number two as strict, but the command over here is different. But the concept is same. That's what I'm trying to say. That different OSs will have different commands. But end of the day, what you do is you identify traffic, you mark the traffic, you map it to a hardware queue, and you mark the queue as strict. Optionally, you can also go ahead and specify these four queues, or let's say I support eight queues, eight queues, whatever you call it, right? I support up to eight queues. However, to queues, let's say if I had like eight queues, like eight of them, one, two, three, four, five, six, seven, and eight. So if I've got many queues, go ahead and what bandwidth would you like to allocate to each of these queues? Right from Q0 all the way to 8 queues. What bandwidth would you like to reserve for each of these queues? Okay, 1, 2, 3, 4, 5, 6, 7, and 8. So if I want to say, hey, I would like to reserve, let's say queue number 2, something, 50% bandwidth. Remaining queues, I don't know, like maybe I want to give like 5% to this one. I want to give 10% to this one. Well, it totally to go ahead and view that queue as yeah, 5%, 10% from that on how much use, like whatever that number is, right? Okay, so I just want to go ahead and check like how much I can allocate to each one of them. Okay, up to me. If you want to do bandwidth reservation, look, this is an example of bandwidth reservation. This is a perfect example of bandwidth reservation. Look at this. Let me get this whole thing that and show you what I'm so I'm saying that, hey, from the given that I have right now, okay, from all the given queues that I have right now, yeah, yeah. So these are my 8 queues, right? Q1, 2, 3, 4, 5, 6, 7, and 8. Yeah. Yeah, from all these given queues. These are the 8 hardware queues. This is what they're doing. Q1, they're saying 25% bandwidth. Q2, 3, 4, 5, 6, 7, and 8. Do you see that? You understand what they're trying to do? They're trying to do some bandwidth reservation. It's enhanced transmission, saying minimum queue bandwidth 35 Q1, 45% for Q3, all the way to maximum number of queues. Like using Q2 as strict, we're giving 45, 0, 1, 2. This is 2, hardware queue number 2. Look at this. This is hardware queue number 2 because queue numbering will 1, 2. You want to give 45% bandwidth. Hope you got it. All good? Wonderful. Great. Great. Just want you guys, I'll tell you what I want you guys to do today. I'll stop the lecture. Okay. Let me explain you, okay, what we are doing today. So today, um, I'll be sharing you. Let me share you the we have today. Okay, there's this iSCSI lab. You'll be using this document, the document that I'm, attaching right now. Okay. Um, so I'm attaching a document. If I open this document and show you what we are doing, basically, remember your station numbers. Okay. Remember your station numbers. Okay, those who are specific. Yeah. So remember your station numbers. Um, so Chuang and Chuang, your station 1. Chuang is station 1. Um, Nguyen and Van are not in the class, so I'll skip them. Sang, you're station 2. Trong, you're also station 2. TC Tan in the class right now. You're station 3. Kwan and Lin are not there. Sedung is also not there. Anybody that I'm missing? Anyone that I'm missing? I have Chuang. Trong is there. Sang and TC Tan. Okay. Hmm. Yeah, I think his name is. He's got a full name as Trong Tien. Sang. His full name. Yeah, so I just easy to pronounce this one. Okay, Trong. Yeah, yeah. So yeah, so that's I'm right. The name in the participant list it says Trong. So okay. Um, so TC Tan, you are yeah. So TC Tan, you're station 3. Okay, so what are we doing? What you're doing basically is in this guide, the guide that I have prepared specifically for you guys. Okay. First, it'll ask you to log into your Windows machine. Ask you to log into your Windows machine, which is this. So here, right? I've got this Windows machine. We will go ahead and change the host name. Okay, we'll be going ahead and changing the the host name. So, which is yeah, so computer, I don't know, computer management or whatever. You go here. It could be here or it could be server manager. Okay, server manager. Okay, over here it talks about how you can go ahead and change your computer name. So you can see the computer name, whatever name you have, there's an option for you to change. So you will be changing your computer names to whatever station number. Like I'm using station 4. I'm using this spare station. I mean, I'm using this one. I'm using this. Yes, I'm using this. So I changed it to station 4. So Chuang will change it to station 1, and Trung will change it to station whatever, station 2. TC Tan, you change it to station 3, and then Sang, you're using station 2, right? So you change it to station 2 or whatever, right? So I want you guys to go ahead and change that station. I mean, your computer name, your Windows name, to your station number. Okay, so it shows you step by step how to go ahead and change that. Station X, X meaning X is your station number. Yeah, 1, 2, 3, 4, whatever your station number is. So you're changing that, and after you change, it'll ask you to restart that Windows machine. It'll go through a reboot. Yeah, so let that reboot. That's all you. Then go to the iSCSI lab. So the iSCSI lab, tells you what we are doing here is we will be using this topology. If you look at this topology over here, station one, and whoever is station 3, you follow the topology to the left hand side. I mean, let me just go ahead and open this on a separate uh, page so that I can. Okay, so let's say this is the topology, right? In this topology, station 1, who's station 1? Chuang is station 1. Okay, and who's station number 3? Station number 3, I don't know who's station number 3. Is that station? Yeah, TC10. Yeah. You will follow the topology, which is like, for example, port numbers 1 and 2. Yeah. So these port numbers are different for station 1 and station 3. Whoever is station 2 and 4, like Sang is station 2, and who else is station 2? The Sang and Trung. Yeah, you're station 2, I believe. Yeah, station 2. So station 2 and station 4, you will refer to this topology. When you this topology, you end up creating VLAN 102, end up creating port channel 102, end up using port number 3 and 4. Whereas station 1 and 3 will use port, 1 and 2. So in short, whoever is station 1 and 3, use this. Whoever is station 2 and 4, you're using this topology. Is it clear? Is my message clear? Do you understand? Okay. You are following this guide, and this guide will tell you step by step, like to go to MXL C switch, have C2, but use the MXL C switch, okay, and start configuring. These are the steps, step by step. Start configuring, MXL, and it says, hey, for station 3, and so on. Okay, so you are doing step by step configuration. Okay, configuration change DE 0/X-X. Now, what is this X-X? X-X meaning on your MXL switch, what ports to configure X-X. So over here, the answer would be if you are station 1, 1 hyphen 2. This should be 1 hyphen 2. If you are station 1. If you are station 2, it says, okay, use 3 and 4. This is exactly why I gave you this topology, saying that if you are station 1 or 3, the port numbers will be 1 and 2. If you are station 2 and 4, the port numbers that you 3 and 4, 3 hyphen 4. It, I'm referring to Sang and Chuang because they 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 talk, they respond. Maybe they understand the language clear. And I want you, Sang and Chuang, to let others also know in the class. If they are not able to get it, please guide them. Okay? Chuang, Sang, yes, no. Did you understand? Yeah, okay. So then when you talk about creating a port channel, if you're station one, use one. Well, I have already put it over here, saying that, hey, you'll be, station 2 and 4 using LAN 102. Port channel 10. If you're station 1 and 3, then you'll be using VLAN 101, port channel 101. So just make sure that you refer to that topology. If you want, I can share that topology separate also, but this is what it is. Okay. The rest is all going to be like, okay, over here it talks about, okay, when you're talking about which ports, you should 1 and 2 if I'm station 1, station 3, 1 and 2. Station 2 and 4, okay, 3 and 4. That's what you need to put over here. What about port channel? What port channel? Okay, if I'm station 4, then my port channel should be 102, my VLAN should be 102. So just and keep doing this lab till the end, okay? Keep doing this lab, keep doing it, keep doing it, keep doing it. And then end of the lab, if you look at this lab, when you reach you configuring, okay? In example, it will ask you to go with an IP address. It says in Windows, it is asking you to configure some port, okay, in your Windows. So if I'm station 4, I'll use slot 1, port number 2. So like this one. If you look at this one, it says here, let me show you that. Slot 1, port 2. I mean, that's what it says, right? If I'm station 4, slot 1, port 2. What do I do? Okay, slot 1, port 2. You go to the properties, you click on this, and you go ahead and configure. Yeah, so you got to go ahead and set an IP address. What IP address should I set it for this one? Okay, sheet saying for Windows, iSCSI. I don't know if you guys can see it, but it says for Windows, iSCSI, you will have an IP address. I mean, this is dark, but just I don't know. They had some. I think there's a color problem or something where. Yeah, but anyways, you have an IP address saying this is the IP that should be configured for ESX. This is the IP address that should be configured for, and this is SCSI target. Sang and Chuang, did you get it? Can you pass that information to your other participants in the class? Did you understand that? Yeah, okay, good, good, good. That is the same IP that you set on that specific slot number. If you look at that slot number, I have set IP address as 172.16.4.21 because my sheet tells me that because 72 whatever. Yeah. So that's how you configure. And I want you to do this complete lab is what you need to do. And once you are done with the be able to get those iSCSI sessions like I told you, right? In case of was that Windows machine? Yeah. Windows machine. I had this initiator. So these your iSCSI configuration was correct. All good. Worked. You should be getting should be able. Sometimes you get the LUN. There's a problem with compellent storage, but that's okay. I mean, as long as I keep, as long as I get this sessions, that's more important for me. I want these sessions. So what are we doing today? So today we will just go ahead and okay. So we'll be doing lab. I'm attaching this. Just give me one moment. Okay. Hi. So we have reached the end of theory session for today. Okay. Please proceed doing iSCSI lab, the attached document. Shall I send you? Okay. So Sang and Chuang, there's no more lecture today. Just the lab. Yeah. Put a new now. Let me put a new note. Okay. So here's the note. Same message. Okay. Next lecture will start at 9:30 a.m. Vietnam time tomorrow, which is 17th of what? 17th of February. Okay. Thank you, Sang. Thank you, Chuang. Thank you, Trung and TC Tan. Any help, do ping me. And Sang and Chuang, please help the other participants if they are not able to get my message clear. Please help them. Please guide them while they are doing labs. Okay. Thank you so much.